Good morning and welcome to Wednesday of week 1 of your Physics 5 a day, and we're starting today with power in electrical circuits. So remember that power is how quickly energy is transferred. So in a circuit we can talk about the input power, so that's how quickly the cell or the generator or whatever transfers energy into the circuit, into electrical energy, or we can talk about output power, or the power of components in the circuit, and that's how quickly they transfer energy out of electrical energy into other forms. So the motor transfers energy into a kinetic store because it's moving. A resistor transfers energy out into a thermal store. All it does is heat up the surroundings. And a bulb transfers energy out also into the thermal store. It also heats up its surroundings, but also some of the energy will travel away as light. So the formula for power is nice and easy. It's just the current through a component multiplied by the potential difference across the component. If you combine that with Ohm's law, you'll get two more formulae. So you can have P equals current squared times resistance, or voltage squared divided by resistance. Power is measured in watts, and 1 watt is 1 joule per second. Okay, time to have a go at a question. Have a go at that one there. Right, now I think it's a bit naughty, this question, because it's not immediately obvious whether the elements and the motor have to be in series or in parallel with the power source. Later in the question that becomes obvious, but it's not obvious at the start. So if you're not sure, you just have to try them. It's a good exam strategy. If you're not sure, you just have to try them both. So it could be that they're in parallel, or it could be that they're in series. Now, to cut out some of the working, it turns out that the parallel arrangement is the right one. So here we have that the PD across the heating element has to be the same as the EMF, so that's 230 volts, and the power is 1.5 kilowatts. Looking for the resistance, and so this is our formula. Rearrange, put our numbers in, and you should get, we'll move it up into view, about 35 ohms. Now remember to write out your unrounded answer, because that will be what they're looking for on the mark scheme.